One more bit on function composition. This time we have no numbers to plug in. We're doing purely algebraic expressions for these. So they're asking us for both combinations. They say do f of g and do g of f. They're not going to be equivalent in most cases. Sometimes they come out the same, but usually don't expect it to. So let's see what f of g looks like. F of g means write function f, first of all, which is 3 times x or whatever you're plugging in. But this time, we're not plugging in x, we're plugging in g of x. And g of x is 2x minus 3, right? So everything in blue is function f, everything in red is function g. And now that we have that, we can clean it up and write 3 times 2x is 6x, and 3 times minus 3 is minus 9. There's our cleaned up version of f of g of x. We can do that the other way around easily enough. G of f of x, start with function g, which is 2 times minus 3. No, sorry, need a little less space than that. All right, now, what's getting plugged into function g? Function f, which is, in this case, 3x. If we clean that up, we get 2 times 3x is 6x minus 3. Done. So this is f of g of x. This is g of f of x. They're similar, but they're certainly not equal. Let's get those out of the way a bit, and we'll see if we can do a couple more. You may not always need to do this thing I'm doing where you leave the gaps and then write in the function. I did this when I was first learning these, and I found that it helped me keep things organized, but if you're really good and can write these just at a glance without slowing down, then excellent. You're ahead of the game. For this next one, we have f of g of x will go there in a moment. For now, we're just putting 3 times blank squared. And what we're putting in here is g of x, which is 2x squared minus 3. Now, when we go to clean this up, order of operations says the 3 has to wait, and we have to square this first. You have to do 2x squared minus 3 times itself, which is going to give you 4x to the 4th minus 12x squared plus 9. I'm foiling that, as you probably realized. I'm just doing it quickly to try to save some room. And then when we triple all this, we get 12x to the 4th minus 36x squared plus 27. That's f of g of x. If we go the other way around, now it's g of f of x will be there in a minute. G of x is 2x squared. Oops, sorry. I don't want to say x, though. I need to leave some room so I can put in the other functions. So it's 2 times ahem squared minus 3. And what goes there? Function f, which is 3x to the 2nd power. Now we can calculate that. It's 2 times 9x to the 4th minus 3, which is 18x to the 4th minus 3. Fair enough? One more. Well, one more item, 2 more compositions. If we're doing f of g of x for this last set, function f is 3 times blank squared. And what we're putting into it is function g, which is 1 over 2x minus 3. Now we get to square all that, which is going to mean 3 times 1 squared is 1. That's not too bad. 2x minus 3 squared gives us 4x 4x squared minus 12x plus 9. And now we have to triple all that, which actually is not that bad. Think of this as 3 over 1. You simply get 3 over 4x squared minus 12x plus 9. There's minus. If we go the other way around, do g of f. Here's function g. We'll leave a blank for whatever's getting plugged into it. And function g is 1 over 2 times blank minus 3. Okay. 1 over 2. Normally there'd just be an x in this space, but now we're leaving it empty. And what's going in there? Function f. There it is. And it is equal to 3x squared. If we pretty that up as much as we can, we get 1 over 2 times 3 is 6x squared minus 3. I suppose you could factor a 3 out of that. I'm not sure it's worth it. You'd get to 1 over 3x squared, 2x squared minus 1. I don't think that's better. I think I would stop right here. If you are passionate about factoring, then fine, take the 3 out and you'll get this expression, and either way we'd have to stop there.